Okay, I'll start introducing you now. Hello, everyone. Thank you for joining DataCon LA 2021. Welcome to the Data Engineering track. My name is Eli, your host, and our co-host today is Lori. We will be moderating the chat and Q&A for you during the session. Today we have as our guest Roksolana Diachuk, and she will be presenting Alice in the World of Machine Learning. Roksolana works as a big data engineer at Captify. She is a speaker at technical conferences and meetups, one of the Women Who Code Kiev leads and mentors. She is passionate about big data, Scala, and Kubernetes, and she always loves to learn something new. Her hobbies include building technical topics and fairy tales and discovering new cities. Without further ado, I'll hand this over to the speaker. Thanks for being here, Roksolana.
Thank you. I'm delighted to be at this conference and just happy to present this talk. So this is going to be an adventure of Alice in the world of machine learning. So as it was said, I work as big data developer at Captify. Captify is a British product company. It's the largest independent holder of user search data outside of Google. Also, we are hiring in both London and Kiev in Ukraine, where I'm based. I'm diversity inclusion ambassador there, and I'm also part of the Women Who Code community in Kiev. So I've built a series of talks around Alice adventures in different worlds, basically tech worlds. And in order to understand where we are currently in the story, which is kind of a short part of the story, I will give like a short recap of her previous two adventures. So we would understand what she learned over this time because she interacted a lot with Scala and Kubernetes, and we'll get to the point of her diving into machine learning world. So in her first adventure, Alice traveled to the world of pods and higher order functions, where she went to the functional forest and learned more about functional programming, the monads, the functors, and then to the Kubernetes world, where she understood more about the pods, the replica sets, deployments. And her learnings over this adventure were about the actually similarities between functional programming and Kubernetes. So she learned that they are similar by the kind of a type system, because in functional programming, we work a lot with types and their hierarchies. In Kubernetes, we have multiple objects. And why it's important for the machine learning, because some of the frameworks are built on top of Kubernetes. So in Kubernetes, we have like pods, replica sets, and deployments, and they kind of build a hierarchy type system. Another important concept is immutability, heavily used in functional programming, where we kind of recreate new objects. In Kubernetes, we don't have kind of immutability as itself, but usually when we operate objects and we want to change the name of the instances or replicas, we would definitely kind of recreate the object from the start, which means it's sort of immutable. Another concept is declarative nature. We heavily rely on the concept as engineers, because we don't go into the details of how things work behind the scenes, like the machine code. We usually operate with the high-level concepts of the programming languages, which means that we don't really get into the details of how it works like there. We just get some purpose we want to achieve, and we build some general high-level steps to do that. In Kubernetes, we can do that by specifying the YAML files with object description, and Kubernetes kind of handles it all for us behind the scenes. We don't know how it happens specifically. Obviously, we can learn how it works within Kubernetes, but as users, we usually just create an object, we get the object running, and that's like all we care about. And another concept is DSL, or domain-specific language. So in functional programming, it's usually functional language or framework language. In Kubernetes, we can specify YAML files as DSL, because it's kind of a language in itself, where we get to learn how to set up different options, how to create objects, and so on. So during this adventure, Alice learned how to create Kubernetes objects like pods, replica sets, custom objects, and eventually she created MagicDB, or Magic Database, which held all of her knowledge about the world where she traveled to. And this custom object had pods, and also she built a database persistent storage, which kind of looked like a safe lock. So eventually she decided to kind of steal it just to keep this knowledge with herself, and also a pod tagged along with her to her usual world. Her next adventure happened 2 years later, where she got older, she became Scala developer and traveled to, again, the same place where she found this path to the functional world. And there she found that persistent volume or safe lock, which stored all of her knowledge and she totally forgot about it, and the pod, which was living there just all of these 2 years in her usual human world and kind of was longing to get back home. So as Alice was into Scala at the time, she decided to build a link between Scala and Kubernetes, and using Scala code, eventually she built custom object called launcher or rocket, which would basically move the pod to his world. And she launched this object, it worked smoothly, and eventually the pod got back home. So where we are right now, 3 months passed all this time, and Alice was really working hard. And when she came back from that adventure kind of vacation that she had, she decided to change something in her career. And she was a Scala kind of backend engineer. And at the time, she decided to focus more on the big data engineering. She found it really exciting, new sphere. And at her new job, on one of the days, she met Jane, data scientist, and she just asked her whether Alice knows how to deploy machine learning models. Alice didn't have any knowledge about that. She obviously knew about machine learning in general. She kind of understood how it worked in general, but she wasn't really interested in that before. And she was at the same time wondering why she was approached about that, because she never really said anyone that she's interested in something like that or that she had experience with something like that. So she decided to ask, but what exactly the machine learning model they would want to deploy does in general? Because again, just possessing some understanding of how machine learning model work, she knew that in order to actually deploy the model or serve it, you need to understand the nature of the data. And basically, it's the most important job of the big data engineers to work with the data itself, with data formats. Therefore, we need to heavily rely on the nature of the data. We need to know what kind of transformations should we perform. And with deployment, she needed to know basically the input and the output. And Jane explained that actually it's an entity recognition model, which means that we get some data and we extract specific entities out of that. In this case, this input data is search queries of the users. So Alice decided that it sounds kind of exciting, but why exactly she was approached with that question? Because again, she didn't really show any interest in that. And Jane explained that actually data science team heard that she had experience with Kubernetes, and Alice didn't hide that at all. She was very excited about infrastructure in general. And some of the deployment mechanisms and frameworks relied on Kubernetes, and just her understanding of containers and how things work would definitely help her with deployment if she would want to do that. So they really needed help of Alice with deploying these models to build some kind of proof of concept, just to understand what kind of frameworks they would want to use for that. And since Alice obviously had more experience with containerization, she would be the best person for the job. And Alice agreed on that. So she digged into the research. What she had in the beginning is the input data for this entity recognition model, user searches. The entities would be anything including the cities, which is like geographical location, some indication of time. So we basically need to classify each word in the search and understand whether it's some specific entity or just service words. We have those. whether basically this phrase has a meaning to us. So the model does that, and the output would be these classified entities. Alice was working late to investigate what kind of options she has in terms of tech. And a few days passed in this working spree where she researched different approaches. And she had multiple ideas in terms of frameworks she would want to use for that. First would be self-hosted solution, which means it's a very customizable way to serve a model. It can be kind of a service which can be deployed via any cloud services like AWS or Google Cloud, or it can be hosted on Kubernetes as well. But it requires a lot of work, and it might not be reasonable for POC in general. Although it's very customizable again, because it can be tailored to the needs of specific model. So Alice decided that she wants something kind of more automated and more out of the box to try out. And in the future, if they would want to, they might be able to move to some self-hosted solution. One of the candidates for the more out-of-the-box tool would be MLflow, and it's a Databricks framework which covers the whole pipeline and helps to automate every step of building machine learning model, not only serving of the model, which looked very nice for Alice. Another option would be Kubeflow, which looked even better for her just because it was based on top of Kubernetes, and she thought that it should be familiar, at least in some way, for her. And again, it covers the whole life cycle, going from data pre-processing to building machine learning model and deploying it. The trick here is that you need to kind of cover all of the steps, not only the serving one. And there are other Clipper and Seldon, also open source frameworks. They usually operate with only a serving step, which would work in this case as well. But they are not very expensive for the future. So Alice was thinking what she should use. And actually, the idea of using Kubeflow was very exciting for her because it was based on top of Kubernetes. She already had knowledge of that. Plus, it has a great potential for a data science team as well, since they would be able to build pipelines out of the box, not only the serving step, and kind of automation of the whole machine learning processing. So Alice decided to dig deeper and understand how Kubeflow works. So this is, we can imagine it as a pipeline of building machine learning model. We have a data ingestion step where we get the data from either an API, it can be some storage system like S3 bucket or Google Cloud bucket. And we read the data, usually big data engineers do that. We build some analysis on top of this data. So analysis means we need to understand whether a specific data set is suitable for us. Maybe we need some transformation, some processing, and it's one of the important steps in terms of building machine learning model itself, because it helps to understand whether current data is suitable for us, whether we need to, what kind of values basically some fields have, what kind of types. It's all important here. So later, some transformations can be built. It can be anything like conversion of types, changes of precision of values, maybe combinations of multiple fields. We can build totally new fields by some calculations on top of the source data. And the next step would be validating the data. So when we build validation, it means that we need to figure out what kind of ranges of values we have. Again, why it's important? Because we might have some zero values, and therefore we might filter them out in the future, or we might kind of rely on the ranges of the values for our features. We should know like what kind of values could be for a specific field, or it can be even like a Boolean value, depends on the purpose. And then the actual features are built, machine learning model is trained, and the next step would be evaluating this built model and validating that the results are actually correct. So the whole process is iterative, which means that we can actually get back to the previous step or a few previous steps back. So after evaluation, we might realize that the model is not very good, and we can get back to analysis of the data or transformations by building some new transformations or removing some of the features. And then we might retrain the model, again validate it, and then think of probably serving the model. After that, we will definitely need some logs in the process, some metrics to realize how it works. And it can be also evolutional way of building a model, because after that, we might need to build one more model or improve this one, and so on and so on. So it's quite kind of changing process. All of the components that contribute to building this pipeline in Kubeflow include central dashboard, which is kind of a front end or user interface, which allows to manage everything around Kubeflow. We can see some metrics, some logs in there, some visualizations of the data, some model visualizations. We can work with the jobs launching, pipelines launching. So it's basically a place which kind of connects everything in the Kubeflow. And it's very visual. It's easier than just working with subscripts. Another important component is Kubeflow Pipelines Ar. It's a framework that basically allows to run pipelines of our jobs. Pipelines might include one or multiple steps depending on the needs. Usually, a pipeline include a few prepared steps like data preprocessing, model building, and training. So the pipeline would consist of these components. Another component is Jupyter. Jupyter is famous for all of the data scientists. It's basically a shared environment for running notebooks. So multiple data scientists can collaborate. They can create their own models. They can run specific cell or multiple ones. And Kubeflow allows to launch Jupyter notebooks directly from user interface. Another component is KDIP, which is for tuning machine learning models. In Kubeflow, it's possible to tune machine learning models automatically just by providing a way of tuning. It can be via neural networks or not. We can just choose an algorithm for hyperparameters tuning, and that's it. Like the Kubeflow would launch multiple models and figure out what would be the best values. Also, ranges of values for parameters can be provided. Another component is Kubeflow serving, Seldon, or Tensorflow. So there are multiple ways to serve the model. It may depend on the framework with which the model was built, like TensorFlow, XGBoost, and so on. Usually, if you would build the model with TensorFlow, we would serve it with TensorFlow as well, but it's not a requirement. And it's built via Kubernetes custom resource definitions. Another component is TensorFlow Jobs. They are used, again, there can be a Kubeflow job or TensorFlow job specifically. It doesn't matter whether the model was built with TensorFlow or not. They just help with control to data, some garbage collections, more like kind of work around models, not the model specifically. And MinIO is a storage system for the pipeline artifacts. Artifacts might be logs, metrics, everything that the kind of the model produces. And also Istio, kind of a component that works more like behind the scenes. So it's not going to be evident for the users of Kubeflow. So Alice is kind of a fan of Kubernetes, and she was curious to see actually which components of Kubeflow are tied to the Kubernetes components. For example, Central Dashboard is actually an ingress gateway. It's an ingress service, so we need to like port forward from one place to another if you want to set it up separately, not within some cloud system. And therefore, we just use it as a service. Kubeflow pipelines or Argo are built on top of Argo workflows. It's an open source framework which provides possibility to build workflows. It's a bit limited in terms of why we use Kubeflow instead of just Argo workflows directly. Those workflows limited in terms of usage Usually we would set it up with some bash scripts, while Kubeflow is kind of adds up to more advanced possibilities on top of that. Jupyter is set up via a service, and the service accounts like role-based access to Jupyter's multiple notebooks running, and so on and so on. Tensorflow jobs are running via Kubernetes operators. So quite good because operators allow in Kubernetes to set up something custom, like custom definition of the YAML file, because usually we have some generic options that we might be able to have in YAML file, not anything customizable. But the Kubernetes operators allow to customize the files, and we can set up anything related to TensorFlow directly in YAML file. Kubeflow serving and Seldon and TensorFlow serving are set up via CRDs, as I mentioned, or custom resource definitions as well, which is easier for customizing the way we are going to actually run the jobs. Min.io is set up via a volume. It's a concept in Kubernetes where you are able to kind of store the data in a persistent way. It means it doesn't depend on the lifecycle of the object. So in this case, when the model goes from each of the steps of the pipeline, the data after this run still stays in the storage. With other volumes, it doesn't work that way. Usually, if your object like finished working, just got from running to finished or failed, whatever happened, the data is removed because it's tied to the life cycle of this object. But it's not the case with persistent volumes, which means that we can have all of the logs and metrics stored persistently, like as much as we want them to be stored, and we can view them later, which is comfortable for analyzing things. And Istio is a service mesh, which allows to kind of control multiple components behind the scenes.
Just to let you know, Roksolana, about 10 minutes left for your talk.
Okay, thank you. So Alice knew that she would be able to either set it up all directly via like local environment, local Kubernetes cluster, and wasn't really the good way to do things. So she decided to rely more on some cloud providers like Google Cloud. And via Google Cloud, she would be able to set up multiple services, like a list of those, and they allow to use Kubeflow kind of like out of the box. But obviously not all of the cloud providers allow to do that. So now she had a Kubeflow setup, and she would be able to play along with that. Alice was really excited to see what she could do with the model specifically, since she already had the model. So what's going to happen next? She has a pipeline, as I described previously, and these are the steps that she defined. The data preprocessing step, the actual model training, and the model deploy. So all of those steps should be containerized via Docker in this case. And the pipeline execution would look like this. Actually, this pipeline execution is very similar to the way we create objects in Kubernetes. So we have some file in Python, component py description of our component. We supply this file to DSL compiler. Compiler kind of generates YAML file out of that, supplies it to pipeline service, and then we relate to actually API server of Kubernetes specifically. We create out of this YAML file some Kubernetes objects. In this case, it's going to be custom objects, CRDs. CRDs also have pods, and you can see here that pods also contain some logs and some metrics as like a visual way to present it. And as soon as we get that, Argo controllers step in and they control the life cycle of those pods. What's happening to them? Are they running? Are they failing? Whatever happens in the process. And they would be able to kind of message the API server, and then some other components kick in to figure out what's happening. So component is only one step in Kubeflow pipeline. It's kind of the way it looks like. It can be the beginning of the pipeline, the middle, the last component, anything. And we are going to look into the component specifically. So we have a source code for this component, a Docker image, a YAML file that describes the input and output of the component, the bash file which pushes the Docker image to the Docker registry, and the README file, which describes what's happening in the component. So the source code is supplied by the data science team. Everything else Alice should set up herself. So Alice was a bit confused where should she start from, and she decided to actually take one of the components and go from each of the steps and then repeat it for all of the others, since it's the way to actually build a pipeline, and then she could go from there. So she has a Docker file for building a Docker image, the bash script that pushes it to the Docker registry. So the bash script looks like this. Nothing fancy, just an image name. In this case, it includes the Google Cloud reference. The tag, which is the version usually, can be latest, can be any number, just to specify versioning of the image. And the full image name would include both the path and the version. And the simple commands are executed like building the Docker image and pushing it to the registry. So what happens next is that an image is pushed to the Artifactory, and she could see that now she has deploy, preprocess, and train images. All of them have similar scripts, just different namings. Next step is to specify the YAML file, which is the description of this component. So the YAML file looks like this. We have something generic like name and description. In this case, it's a train component. It trains the model. And we have these inputs. Input X is the actual features. Input Y is labels. Input job directory is the directory of previous step of the preprocessing data. Input tags, also the words, which is the result, and the output model template, where she would push the results of the training. And also she needs to specify the output section, which is the URL for the output model. It's all in Google Cloud, therefore GCS path, and the container name, the one she built via Docker. So the command of the execution, which actually going to kick in when she's going to launch the component, looks like this. There is a Python file. We launch Python 3, and all of the parameters are the input and output ones, all the same, like features, labels, input of the previous step, output of this step, words, tags, results of the model as a file. So this is just like general description of this component, and it's a bit different for all of the other depending on their inputs and outputs. So next, she could look into Kubeflow user interface and see what's happening in there. It looks like this. There is a home page. She could work with notebooks, with artifacts from her model, and she could look into pipelines directly. So in order to see her components as a pipeline there, she needs to actually load them into the Kubeflow. For now, we just have a component described, and that's it. So the first step of loading includes actually running load component from URL. It can be loaded from file as well, but in this case, we're going to load it from a YAML file that we have in Google Cloud bucket. And now we have it loaded to the system. Now we have the source code, the YAML files, everything in Kubeflow, but it's not running yet. So what should we do next? Basically, now we have the training component, the YAML file which describes this component, and the YAML file in its turn references the Docker container registry. So we combined all of the steps together. That's why we needed to have a Docker file, a YAML file, and a Python source code. Now everything is together. We just went through all of those steps, so it totally makes sense why we needed all of those things aside from the source code. So the next thing would be to actually set up the pipeline. We need to create it first, then compile it, which makes kind of the pipeline known for the Kubeflow. Then we create experiment. We can have multiple ones and just see the results and change something, and run the pipeline. We also can have multiple runs of the same pipeline. So creating pipeline is rather simple. The pipeline function contains the actual steps of the pipeline described, nothing fancy, and the description of the pipeline in general. So the creation is very simple. The next step, which is important one, is compiling the pipeline. So here is the function for compiling the pipeline is just the naming and the file name. In this case, let it name pipeline zip. It can be any other format, but it just works in our case. Then we call the compiler. We actually compile the pipeline function and provide the file name. The next step would be to create an experiment. So we set up the client. We check if we already have this experiment. It can be, the naming of the experiment can be a number, like experiment 1, so just for testing purposes, or we can describe what's happening in there in general, just to navigate easier. Then we create a new experiment and we run the pipeline. So in order to run the pipeline, we should have the ID of the experiment, like 1 or 3, depends on our imagination, the name of the run, the file name that we created for the pipeline, and arguments. It's going to be a test run, so we don't need any arguments here, but we can supply those if needed. So now she had all of the steps here in Google Cloud connected, pre-process, train, and deploy. And now Alice could have all the time in the world to wait, because it could take quite a lot of time to actually compile those components, run the pipeline, depending on the amount of data, definitely, and how large the file with the pipeline itself. So after some time, she could see that the components are supplied for the Google Cloud, like she now had pre-process, train, and deploy steps ready. And now she would be able to actually run the whole pipeline and see how it works. So Alice decided to complete multiple runs of the pipeline. On the first one, there was some false error, so it failed. But on the next ones, she could see some differences in accuracy scores. So definitely needed some research in the future. But it looked promising for the data science team, since they would be able to look into a specific pipeline run, go through the logs, metrics, and see what went wrong. Quite automated way in this case. So in order to test the model, Alice just used some of the popular user searches about the weather. Let it be weather in London today. And as soon as she clicked test, she got this result of the predictions. So the classification would be weather is a natural phenomenon. Oh, it's like a service word. We have in, so it doesn't classify as an entity. London is an entity in terms of geography, a city, and today is a time indicator. So all of the entities were classified. So Alice was really happy that it worked, and for proof of concept, it was a great result. So on the next day, she met Jane from the data science team and delivered her results. And Jane said that it looked really great, and they thanked Alice, and Alice was happy to kind of do this research and find something new. And she felt really empowered, because during this research, she was able to learn Kubeflow from the start, to get more understanding of the machine learning models, and to kind of tie it up all together, and even use her knowledge of Kubernetes, which was really great. So then she got back to her laptop and decided to look more into user interface, just explore the things. And what she saw there was this, plots and high order functions are in danger, which meant that now she had to find a way to get back to that world and save Kubernetes and functional programming worlds. So the story to be continued here. Thank you for attention. I hope it was useful. And also I wanted to mention that I use Kubeflow for machine learning models book as a resource for learning more about Kubeflow, experimenting. It has a lot of practical examples. So if you want to start out with Kubeflow or just get the understanding into deployment process, which is also a great book for that. So definitely use it. And it's already available. And here's my contact info. You can find me in Twitter, GitHub, LinkedIn, and I posted my slides in Speaker Deck. Thank you again. Please ask any questions if you have those.
Yeah, and anyone can ask questions now in the Q&A. Please do that. We'll monitor that. We've got about 6 minutes left, so ask away. I have a question. So the steps, the stages that you save in Google Cloud between the the pipeline phases,
Yeah.
uh, is that also stored in the cluster as a persistent volume, or is it stored outside of the cluster?
Yeah, okay, so in this case, the Kubeflow was set up via Google Cloud, and therefore all of the Kubernetes objects, like we have a Kubernetes cluster in Google Cloud in this case, they are set up via Google Cloud as well. Therefore, some artifacts of the model, as I explained, are stored in persistent volume, which is in its turn is in Google Cloud. But if you would set it up, for example, locally, which is also possible, you would be able to like use a persistent volume specifically. It can be stored locally or in some another like system. We are able to specify that when we create persistent volumes.
Cool.
Thank you.
Yeah, I've been thinking about investing or investigating into Kubeflow for my business, but we haven't made that step yet. We are containerizing things, but we're not. We haven't made a Kubeflow change yet. So this is very interesting for me.
I think it's becoming more and more stable, so it's a good place to research.
Yeah. I just listened to a podcast on Argo that was about the future development of Argo, and they still have it in mind that they really want to be stable so that things like Kubeflow can maintain their stability and stuff like that. So that was nice that they're thinking about Kubeflow.
Yeah. Also, when I learned about Kubeflow, I was kind of surprised how many things work behind the scenes, like the Argo, other things. So I think it's a lot of components, kind of complicated ones, instead of just basic pods or any other objects in Kubernetes. Even a service mesh is used.
Yeah. So the controller web interface thing is an ingress gateway.
Yeah.
Is it one of Istio's ingress gateways, or is it a separate type of gateway?
It's a separate one. Also, when setting up locally, you can kind of port forward from your local machine to this ingress gateway. So kind of you can play around the configuration there as well.
Oh, we've got a question. Can components in Kubeflow maintain state?
They can produce state in terms of artifacts. So as I said, that the state is saved separately in persistent volume, and some of the components state is saved by default, like logs and metrics. We can also specify if you want to store some output of the model, which we usually want to do, or some output of the components, like the data, the model itself, the results of the model. So we can store them all in persistent volume as well. Thank you for your question.
Okay, and there's a follow-up question. Oh, sorry.
Yeah. Follow-up question. If we have a memory-intensive model that we want to keep in memory across multiple invocations, is that possible?
Yeah, I think it's possible, but it might be needed to research more regarding the resources of the cluster itself, I think, and how much of this data can be stored like within each of the steps, like in memory, but it's possible to do that. It's usually some of the artifacts are stored like outside because it's just easier to access later, and it can be viewed like via Kubeflow. And if you would store something in memory and we would want to access it later, it might be a bit more complicated. But if it's just like some internal state, I think it should work.
We're out of time, so I'm going to close this session. Thank you, Roksolana, for your presentation.
Thank you.
A great presentation, and the attendees for the questions and interactions during this session. You can contact the speaker directly if there are any further questions regarding the topic. Please provide your feedback using the form that was provided in the chat box. Thank you again, everyone, for joining today's presentation. I hope you have gained some insights from the session. Have a wonderful day, and thank you for being a part of this year's DataCon LA. Thank you.
Thank you. Thank you. I enjoyed it. Goodbye.
Bye-bye.